Good morning, everybody. Just share my screen. George, can you just confirm you can see that, okay?
Yes, we're all good, mate.
Perfect. Right. So, yeah, good morning, everybody. My name's Jamie Birch. I'm the Director of Sales here at 3TI. On the panelist board there, you'll see Sarah Thompson and Ross Jones. Those are two of 3TI's key account and business development managers. And then Ryan Sherritt as well, who is our development lead. He works on the technical side of the project. So just introducing now, they'll obviously be part of the Q&A, contact information at the end of the presentation. Sarah and Ross, I don't know if you wanted to say hello quickly.
Yeah, good morning, all.
Yeah, good morning. I thought I might see some faces on there, but yeah, I'm normally used to Teams, but yeah, nice to meet everyone who's on the call.
Great. So, right, we'll get into it. Papillio 3, smart solar EV charging hub. So, first of all, what we'll do is we'll go through sort of the core products itself. So as you can see here, this is Papillio 3. It's based on a 40-foot shipping container, UK manufactured. It's actually a UK recycled shipping container. What we use the unit for is essentially a platform to encompass three technologies. Those three technologies being solar PV, which you can see on the roof. EV charging, we've got 12 charge points in here, and then optional battery energy storage as well. So left to right, we'll just go through some of the the key factors and bits of information about the unit itself. So, although we are using solar PV on the roof there, solar PV is only actually supplementing. There's not enough solar there to provide full performance for all 12 of the charge points. So we still have a grid connection. That grid connection can be anywhere between 150 and 250 amps three phase, and we also need a wired internet connection. Now, very high level, that's the only point of connection we will need between the unit itself and building or substation or feeder pillar. It's essentially a three-phase switch. We're running out, obviously, 150 amps will give you less performance than 250. But what we'll do is we'll work with the existing grid connection on the site. And essentially what we're doing there is we're providing varying levels of performance subject to the number of charge points that are in use, subject to whether obviously the sun shines out, and subject to what our limitation might be in terms of the size of the grid connection. Now, fundamentally, what we're doing is dynamically load managing with our central piece of proprietary software. And the reason we're able to do that is because we've got control and obviously oversight of all of the different technologies that are sat in this particular unit. So 12 times up to 22 kilowatt AC charge points. So, we're talking about medium to long dwell times, anywhere from sort of 2.5, 3 hours upwards. Your destination, your fleet vehicles overnight, and also your workplace type applications where vehicles are going to be parked for upwards of 2 to 3 hours, as I said. Um, Although we deliver the core unit with AC charge points, we have options for hybrid versions of the unit, so we can introduce DC charge points. We've got 30 kilowatt DCs on one of our units. It was an Innovate UK government funded project, so that's running 12 30 kilowatt DCs. We've got options around 50 to 60 kilowatt DCs, options to add on 120 kilowatt standalone charge point DCs on the end. So although the core product here is 12 by 22, there is, should I say, flexibility around DC options as well. You'll see, obviously, we cut the center out of this shipping container. What we use is the two end pods and in the central column, essentially as mounting position or housing area for the charge points. So you can see on the front face here, we've got two charge points on the front. There's two, obviously, on the reverse, two on either side of the pillar here, totaling four, and then the same essentially on this pillar, or this pod, should I say, on the right-hand side as well. It's all the standard stuff that you get with charge points now. So contactless payment terminals, we use a PAX. I think it's the IM30 at the moment. There's six of those across the unit. So this is an old image, but essentially there's a PAX terminal between each set of charge points. Applications, so back office wise, we use Fuse at the moment. There's options around Monitor, but the unit can be used with pretty much any back office provider. If you've got a particular customer or you yourself have a back office company that you'd like to use. Charge cards, so that's your standard Electroverse, that's your All-Star cards, that's your power cards and so on, which I know lots of salary sacrifice or fleets and things would use. And also RFID cards, so we can offer RFID key fobs or cards. So if you've got a fleet of vehicles or staff that you'd like to allocate RFID cards to, you can just turn up to the charge point, plug in, and essentially tap and go. So the left-hand pod there, as you look at it, just a bit of background in terms of the technology itself. So that is essentially our plant room. In there, we've got what we call our 3TIG control system. This will house things like the distribution board, the inverter for the solars in there, all of our power connections, internet, server, PC, fire suppression system, a hard drive for the CCTV and so on. Everything is housed essentially in that left-hand pod there. The roof is currently covered by roughly 20 kilowatt peak. The JA solar sourced through Segen, but solar PV is roughly 20 kilowatt peak. Obviously, one of the benefits of that, similar to a solar car park design, is it's a fully sealed roof. So essentially, it's a shelter. In the event that it's raining or in the event that it's sunny during the summer, it provides shelter. Obviously, shade, but also stops you getting wet, stops your cable getting wet if you are plugged in and charging. Charge bays 2.5 meters wide, so pass compliant parking bays. This essentially means that we're taking 14 of your existing 2.4 or 2.5 meter bays and converting them into 12 charging bays. So you will lose 2 bays in the parking in the car park, but benefit obviously is the fact that we are then pass compliant. We're also able to use the existing car park layout as long as we've got 14 back-to-back parking bays, as you can see here. So the wing position themselves, coming back to the shelter there, can be in an upward or downward position subject to the orientation, due north, obviously due south. We can have them in the wing up or wing down position, but we'll show you a bit more about that on one of the images in a little while. Sensor controlled lighting and CCTV. So we do have built-in CCTV as standard. Obviously, lighting is good in the winter. It provides a well lit and an appealing sort of place to go and charge your car. Essentially, you can see what you're doing, which is obviously good news. Right hand pod is essentially empty when the unit's delivered, but it's optional battery for up to about 250 or 280 kilowatt hours. If we go sort of quite power dense lithium ion, so automotive grade modules, we can get around about 0.5 megawatt hour in there. But typically from a commercial offset to performance in terms of size of installed capacity, the 280 kilowatt hour or 250 kilowatt hour is around about the size that we would typically install. And then, although there's no image on this one or no media screen on this one, there's options for media screen for advertising purposes as well on the end of the pods, but also on the front face, the larger front face as well. So what does that mean from an ESG point of view? So that 20 kilowatt peak or circa 20 kilowatt peak will provide on average across the UK around about 18 megawatt hours of solar PV or solar electricity over the course of the year. Offset in terms of tons of carbon, that's around about 3.6 tons greenhouse gas avoided or reduced. From a financial point of view, if you're paying roughly 29 pence per kilowatt hour, that's around about £5,400 saving on your electricity bill. And I think for me, this number at the bottom here is quite telling. The solar generation from the top of the canopy will deliver approximately 64,000 equivalent road miles. So you've got from the solar generation per annum over the course of the year, roughly 64,000 miles of EV charging provided by the solar alone. Our motto as a company is driving on sunshine, and literally for 64,000 miles of those, you are literally driving on sunshine. So deployment and installation, site preparation. So we talked about the power cable coming out to the left-hand pod, or it can be the right-hand pod. The unit can be orientated in either way. But essentially, we're looking at 14 back-to-back parking spaces to provide 12 EV charging bays. There are zero foundations or concrete. So the Papillio is designed just purely to sit on the surface of the car park. It makes it very easy for us to deploy. We're not digging down. We're not putting concrete foundations in place. We're not spiro fixing. There's no ground anchors or anything like that. No chemical anchors as such. So the unit's designed just to sit on the surface. So the only bit of digging or foundation work that we need to do in advance is purely that duct, which is going to run the power cable. There are options for surface mounted cables as well. So it doesn't always have to be buried into the ground, but fundamentally you've got a single duct, 150 mil twin walled, and then a smaller duct as well to carry the internet connection. The electrical works obviously need to go through that duct. Connection at the point of connection, which I mentioned earlier, can be the LV distribution board. It can be a substation locally, or it can be an allocated feeder pillar for the unit itself. But fundamentally, the electrical works from there and internet connection. We would turn up on site, remove the existing parking bay markings. So that's just a case of burning off the existing paint and paint the new lines. So from a site preparation point of view, typically, obviously this is very indicative subject to the size of the project, length of dig, etc. But you'd be looking around about sort of 2 to 3 weeks typically for site preparation. We then move on to the day of deployment. So you can see the picture in the center there. We are a B Corp as a company, 3TI, and we're very focused on our carbon footprint as much as obviously offsetting carbon with the EV charging and solar PV there. So we use a single truck. As you can see, the 40-foot shipping container, because it is dimensioned as a 40-foot shipping container, fits on the back of a standard 40-foot shipping container trailer. The tractor unit itself's got the high ab, so the crane itself all built in. And I've got some more pictures of that, which I'll show you in a minute. But fundamentally, it's a single vehicle to site. Vehicle would turn up. We would unload the unit using the boom. You just about see it, the yellow boom on the top of the unit. It's craned and lifted round into position. The wings are lifted up into their correct orientation. We literally plug it into the electrical connection. It's fully pre-tested and commissioned at the base where it's manufactured in Norfolk before being shipped. So that allows us to literally plug it in, quick test and commission to NIC spec on site. All being well, we just hand it over to the customer. Now, we talked about sort of 2 to 3 weeks for site prep. Day of deployment, we claim 24 hours. Typically, it's closer to 6 to 8 hours. The quickest one we've deployed is about 4 hours. So, when we talk about deployment installation, it's minimal site preparation. It's a single connection. It's not multiple different sites in terms of, multiple different powers coming out. Zero foundations and concretes. We're painting lines. We're turning up and we're dropping it on the ground. It's as simple as that. Thereafter, 3TI will then essentially manage, following the handover, the full operation and maintenance of the unit itself. Now, I'm not going to go through this list because I've got another page on it that's a bit more detailed in a minute. So this is the unit down in Medway, down in Kent. So this is actually Segen's training academy down at Wincanton. So this is the unit arriving on site. It pulled into the car park from essentially behind where the Papillio here is in the top left image. The truck, as we see, removes itself from the trailer, will set up in position. The high ab is used to then bring the unit round, put it into its final resting place. Now, in this case, we'd actually pre-painted the lines. So all of the groundworks, power cables and things are in place. Lines are all painted, and that gives us these squares to essentially aim for when putting the Papillio in place. Wings are lifted up into position, and within a day, so the same day there before it's dark, the unit is actually installed, it's connected and handed over to the customer. So it's an image there of the unit in place, just from another angle. I mentioned earlier about the optional media screens, so the Segen unit has got the media screens, just to give you an image there. And you can also see we've got the wing up, wing down position. Now that's because this car park is essentially south facing. So we've got the wing in the down and the wing in the up to maximize the solar generation, given the orientation of the car park. Big benefit of that means that we can use the existing car park in the existing layout without needing to obviously change the layout of the car park to optimize the solar generation. So this is what I was talking about in terms of the fully managed service. So there is a fee for operation and maintenance per calendar month, but fundamentally for that fee, we remote monitor essentially the full operating system. So we've got our proprietary software sat in the center there. So we're monitoring solar generation, EV charging, performance of the charge points themselves, everything around the PAX payment terminals, and obviously ensuring everything's maintained and working essentially. Across our 18 units we currently have deployed, we've got more than a 99% uptime, and that's essentially because we're able to monitor if and when an issue occurs, and obviously respond remotely to recover that essentially as quickly as we physically can. So, we try and make it as simple as possible. We're not a charge point operator. We don't provide our own, charge point head. We don't manufacture solar panels. We're not, importing inverters and things ourselves. We're using off-the-shelf products that are supplied through Segen. We're bringing them together, and essentially the piece of where we essentially make this work is our proprietary software, which sits in the center of it. So yeah, hassle-free operation, that's what we're essentially trying to do here. We are hardware and software agnostic, which means we can use a series of different back offices. I think I mentioned that before anyway. So yeah, customer and driver support 24/7. There's contact telephone numbers on there. You can just about see it on the top of the label. So we're maintaining and monitoring at all times, 24/7. All the electrical and mechanical care is included. That's all the the annual inspections. That's cleaning of the solar panels. It's quite good because we've got monitoring on the inverter itself, and because we can remote into that, we can see if the efficiency drops off. That might indicate that the units need a clean, for example. The modules need a clean. All the solar battery systems are monitored. We're working on constant over-the-air software updates, software improvements, and so on to optimize and maximize the efficiencies of the systems themselves. Easy payments, roaming, smart charging. We're doing everything as much as we can to ensure that we are market leading, or at least in line with market leaders there. It's all about robust and reliable uptime. Safety and security, so CCTV, we've got fire suppression built in, heat detectors, backup systems, all that kind of stuff. So, again, as part of our 24/7 remote monitoring, if there is an issue, i.e., temperature increase somewhere, we get an automatic flag. It raises a fault in the system or a ticket in the system. It's monitored by the full product and technology team on our side. And if there's an issue, we can very, very quickly identify that through software, but obviously backed up then with the human person as well. And then display and communication. So if you've got, let's say, a site, leisure centres are very good, the training academy is very good. If you've got upcoming events or something that you might want to advertise or talk about, the advertising screens are very good. Silverstone use theirs a lot for various events that go on, for then advertising various watches and so on, subject to the nature of what event might be happening over the course of the weekend. So just talking a bit more about 3TIG, this is our proprietary smart technology or smart control and service system that sits in the center of the unit. Very high level, the image on the left is showing all the data connection points or the comms between the different components. So I mentioned earlier, we're bringing EV charging, solar PV and battery energy storage are kind of the three core technologies or products that we're bringing together there. There's lots of electrical, obviously, connection points, but also the comms between your flex providers, your grids, your back office providers, and so on. Now, the image on the left there shows all those complicated or complex, shall I say, many, many different points of connection between these different components. I was always told, just the sales team, but from a technology point of view, I was always told that if any one of these arrows breaks down, there's a good chance that the unit's not going to be reliable, and there's a good job that it's going to stop working, stop operating, etc. What we therefore do with 3TIG is we have a proprietary piece of software which sits in the center of that. Now, essentially, what we're doing is we're managing all the signals, inputs, technologies, permissions, and so on and so forth through a hardwired internet connection. So it's obviously robust, and we're essentially sitting at the center of all those technologies. So very much simplifying. We're able to obviously auto detect and monitor if there is a fault or a problem that comes up using our software. It also makes us software and hardware agnostic. So if you've got a particular PV panel or a particular inverter or a particular EV charge point or a particular supplier of battery energy storage, we can essentially change the software code or the comms, as long as the charge point is OCPP. We can bring that in, we can connect to it, we can operate with it, and essentially, change the hardware or layout of the system subject to your individual requirements if you have them. Here's some examples of some of the customers we're currently working with. I mentioned earlier that workplaces, destinations, and fleets are the three kind of core user groups that we currently target. We're talking about low cost, low carbon energy here. So we're not talking about parking up at services and firing up a gas or coal peaking plant to send lots of electricity down there and charge you in 10 minutes. We're looking at places where you're parked up for a period of time. Now, obviously, fleets, a lot of the charging we do overnight. That's where the battery is a good application, because we can charge the battery during the day using the solar and some of the grid power if it's available. And then we can discharge the battery along with low cost energy overnight to charge the fleets if they're operational during the day and charging overnight. Destinations, it's a leisure centre in the centre image there. It's actually Wiltshire Council down in Five Rivers. So in these sorts of scenarios, we're looking at people that are coming in for hour and a half, maybe 2 hours, typically charging at sort of 11 kilowatts. So it's really a scenario where you're parked up, but it's good to get a bit of additional charge. It's very unlikely people have really travelled more than 60 miles to get there, but in that time, you'd expect them to get around about 60 miles of charging. And then workplaces. So, a lot of our customers, Segen included there, obviously. Caterpillar have just taken one. Bentley have got two. Jaguar Land Rover have got two. It's staff, salary sacrifice schemes are rolled out. They've got EVs. There's many staff that are unable to charge at home. And as a result, we see very, very high utilization at all three of those sites, Bentley, JLR, and CAT, because their staff come in. It's low cost, it's sustainable. They're only charging circa 30 pence to their staff, which is similar to what they may be paying at home. And therefore, the unit gets used a lot, to say the least. Benefit obviously is in these scenarios, we're not closing the car park down for a long period of time. Once the power cable and things in, we can come in, think on all of these applications on a Saturday morning, have it installed in a day. That's 12 charge points and 20 kilowatts, kilowatt peak of solar installed, in the space of 8 hours, ready and up and running for staff to be charging on a Monday morning. So that's pretty much everything I've got here. Obviously, high level, we'll go through Q&A now. George, I don't know if you can lead that, but yeah, Q&A now. Contact information, I think we'll share this presentation. We've got loads of case studies which we'll include in this presentation so that you've got them for reference imagery and some ideas, of our target customer audience, as I mentioned. Ross and Sarah, key account and business development managers, and myself, director of sales, mobile numbers and email addresses there. So yeah. Any questions, please?
Perfect. Thanks, Jamie. So yeah, just as Jamie mentioned, if there's any questions following on from that, please feel free to type them out into the little Q&A panel that you've got at the bottom of your screens, and we'll go through them. Give you a couple minutes just to warm up your typing fingers if you're getting a question prepped. So Steve, thank you very much, Steve, has asked, what are the planning restrictions for these types of units?
Yes, actually, very good point. Thanks, Steve. I forgot to go through that. So, in England and Wales, England and Scotland, the unit's classed as permitted development. So there's options around prior approval applications to confirm permitted development, but typically these are installed with no planning at all because they are permitted development. The thing's been designed under 100 square meters. It's less than 4 meters in height. There's no change of use from an existing car park to a car park, and solar PV across the UK is now also permits development on car parks. So for that reason, they can be rapidly deployed. Planning is not a concern. In Wales, there are some additional loopholes that we have to step through. For some reason, the council legislation is different, which means that we do have to go through full planning in Wales. I think they're legally obliged to provide us a response within 56 days. And we've got one unit in Wales at the moment. That one was approved with no issues. From a DNO point of view, just while we're talking on that as well, it's purely an application for G99. It sits underneath a 20 kilowatt inverter, which is what we've got in there. It's Solis, so it's ENA, type tested, type approved. So we've never had an issue with the G99, and then just your standard notification for EV charge points as well. We will internally do a wind load analysis. So that's just looking, when I mentioned it just sits on the surface of the car park, that's just looking at essentially whether there's any concern in particular orientation. There's options to put ballast in the units if we need to. Obviously, typically we're looking at having lithium ion or battery energy in there. So as a result, you've got additional weight, but that's all part of the comprehensive work package that we'll carry out initially. And if any ballast or anything is required to support that, that's included as part of the delivery, part of the commissioning.
Amazing. Andy has asked, can you tell us about how this structure interacts with wind?
Yeah, so I just touched on that essentially. It was initially designed, the unit weighs around nine and a bit tons in its standard form without the battery. The wings, or I call them wings, you don't actually want it flying away, but the shelter itself, or the wings, they're actually designed in such a way that they're minimizing essentially the uplift, the aerodynamic uplift. So they've been designed essentially to work opposite to that, and also distort and break down the wind. That's why we have the sort of the ribs or the cantilever type overarching arms that run through there. It is designed, I think, for a worst case. I think it was Germany for wind loading in terms of, for snow loading in terms of weight and so on. And then we consider, I think there's an area in Scotland by one of the coasts up in Scotland that it's been designed around for the wind load, which is, worst case, you go 20% over for your safety factor. And essentially it's, designed in such a way that I'd say 50% of the cases we don't have to put any ballast in. The other 50% we may have to put somewhere between sort of 300 and 500 kilos per pod. But this is all perfectly manageable.
Amazing. Dara has asked, is there any installer training program or specific certs that are required?
So at this stage, no. I mean, it's something that we've been more than happy to provide or work with installers on. At the minute, we've got a very high level, indicative package of work which we can provide. We can bring contractors in to obviously do the works, but equally, installers are more than welcome, or customers are more than welcome to use their own installers. NIC, EIC, electrical cert's the only thing that you would need for the electrical connection. Otherwise, it's just your standard risk assessments, method statements, insurances, all that kind of stuff, just to ensure that the site's prepped in a sensible way. Big part of what we're trying to do here, obviously, is simplify the install. So as I mentioned, it is a straight civil duct with a single cable. It's an electrical connection, and then we take care of everything else. Essentially, truck arriving, unit being landed in position, all the weight loading, lifting of the wings, and the rest of it. So it's designed to be very simple. There's a specification we would share, but that really just talks around the 250 amp three phase and neutral, plus the size of the earth, switching and size of the cable that would be specified subject to the distance from the LV connection point to the Papillio.
Amazing, perfect. Amy's asked a very to the point question, which I appreciate, which is just how much is this?
Mm.
So that's actually a question. That would be a question to your key account manager, actually. I know what the commercials are between 3TI and Segen. What I don't know, and I'm still waiting on feedback from at the moment, is essentially what the sale price would be from Segen. What is interesting about this unit is there's two options from a finance point of view. There's a capex purchase price, which is what it is. I think it's 130K, but you'd have to confirm that. And then there's also a monthly rental option. So rather than owning this or upfronting the capex price, you could just rent it from us through Segen on a reoccurring either 3, 5, or 7 year contract. There's options around hire purchase and so on. So lots of financial options there. But yeah, capex is the key or the core primary to route to purchasing one of these, but also rentals an option as well.
Just to add on to that as well, Amy, just from a Segen standpoint, the Papillio 3 kind of comes up a bit different on the Segen portal compared to other products. So it's not something that you can just sort of buy like you would a panel or a normal battery. You would have to go through your account manager to place that order, and then they'd quote that for you depending on what you needed. We've got exclusive distribution till is it like April, May, Jamie, something like that?
Yeah,
Of
we did 6 months. So yeah,
2023?
will be the Q2 of this year.
Yeah. So we're really excited about that. And again, just go through your account manager for that. Amy, perfect. Um, David's asking if these units are available for the Irish market yet.
So yes is the answer. We would need to do a little bit of due diligence just around legislation. So essentially, we've not deployed one in Ireland yet. We did get very late stage with Jersey. We are looking at Isle of Wight at the moment. We've got various customers around Europe that are interested. So the answer is always yes. For 1 or 2 units, perhaps not. For a series of, five or a joint batch, then absolutely. At the minute, there's options because it fits on a 40-foot shipping container to put it quite simply on a ship, bring it across. We need to check obviously power requirements, legislation for around planning, DNOs, etc. But it would just be a bit of due diligence on our side. So to get one across on a ship or five across on a ship, absolutely. If you wanted more than that, we've got options for essentially licensee models, or we would look at sort of local distribution. But the answer is always yes. If you've got a customer and application, then absolutely we'd happily engage and look to bring them across to Ireland if needs be.
Perfect. Adrian's asking, do you have a figure or weight that you could give him in terms of the actual size of the unit? Would the weight of the units prohibit the use on something like a multi-story car park or something like that?
Yeah, so I think then you'd be looking at point load. We have got the calculations. I don't have them to hand. Part of our standard brochure and data sheet, which is on the Segen portal, that shows the layout, the parking template, and essentially the dimensions of the unit itself. Um, George, how are we going to follow up with individual questions like that? Because I've got the data, but I would need to send that out via a separate email once I've got it to hand.
Yeah, absolutely. So what we can do is I'll send an email out to everybody after this just with the presentation. And then if there's any sort
Okay,
of follow-up questions, if you want to come back to me, and then I can forward it
fine.
back to Jamie and the team if that works.
Yeah, I mean to give some idea, just Everything Electric show, which is an automotive show that happens every year. We were at the XL building. We've been there a couple of times now. Whilst at the XL building, obviously the multi-story car park is underneath the actual exhibition hall. We had the truck in there. We had the Papillio unit itself. I think there was a requirement for slightly enlarged spreader plates, which are essentially a sort of a 12 mil thick mild steel plate that's used to just further distribute the point load essentially across the corner of each unit. I've got a feeling the point load there was something like 3.5 tons per meter squared, something like that. So quite low. But we've got the calculations. Please send the question in. I'm more than happy to follow up with the accurate answer on that.
Amazing, perfect. Paul is just asking for a little bit of a sort of further explanation on the ESG application to the
Yep.
product and businesses. If you could go through that.
Yeah, so obviously solar PV, it's connected to your building. As a result, if a vehicle's plugged in and charging, then the solar generation from the panels will be distributed directly into the vehicles themselves. If there's no vehicles plugged in, i.e., you've got an application or a location that's 5 day working week and a weekend where they're not charging over the weekend, any solar generated will essentially run through the cable back to the distribution board and into the building itself. So nothing is wasted in terms of what you're generating there. From an ESG point of view, 3.6 tons, subject to whether or not the customer wants the carbon credits. We can provide those in certification as well. So, very high level, we're generating solar, it's offsetting against greenhouse gas. And so the certification can be put together and shared with the customer. Yeah, as needed. A lot of our councils are doing exactly this. So we've got 3 or 4 councils we work with. They're doing exactly that for looking at obviously wider picture, offsetting carbon.
Perfect, brilliant. We've got a couple people just asking about the operations and maintenance running costs on each unit. Is there
Yep.
like a typical amount that would be, I don't know, per year?
Yeah, so it's £500 per calendar month, regardless of whether you purchase the unit through Segen or hire the unit or rent the unit through Segen. The operation and maintenance is direct with us as 3TI. So for that £500 a month, you're getting all the remote monitoring, obviously the updates. That includes all your electrical certs and everything that we talked about on that page previously. But that covers all of the solar PV, the inverter, obviously 12 charge points, and then all the maintenance of running. Key thing there really is if you are grid limited, i.e. you've only got 150 or 130 amps, a key part of our operation and maintenance service is the dynamic load management. Now that essentially ensures that when we're charging across the 12 charge points that we do not exceed, that limitation or that cap that you've put in place. High level, we know what the limit is coming out to the unit. We know what the solar generation is doing live, essentially sort of 5-10 millisecond refresh rate. And then we also know essentially what the demand is on the EV charging. So we're able to dynamically load manage subject to those constraints. And that's all included as standard as part of that operation and maintenance fee. As I mentioned, £500 per calendar month.
Perfect, brilliant. We've got a couple people asking about the differences in price of the unit if you were to have a unit without a battery,
Mhm.
so just the solar, and then as a follow-up to that as well, would you be able to install your own inverters and batteries to go alongside the car park unit?
Yeah, absolutely. Yeah, so it's not something that we have engaged any particular customers because we've not been asked that question before. However, we've got a couple of, let's say, funders that are looking at options around supplying their own battery design and battery system into the unit. Fundamentally, when it's delivered with no battery, as we mentioned, it's optional. The commercial numbers are such that we like to install the unit. We like to run the unit there for 6, 8, 10 months, gather some data and commercially understand whether or not the battery or the additional cost of the battery is financially viable. But that said, there is an empty container there, and that's designed to be housed or to house racking for modules and an inverter and so on, plus DC-DC converter and so on. So, we're a long way down the design route in that we've got to design. There is a period of time and a cost associated to installing the battery, but we've got the knowledge, the experience, and the ability to be able to do so. If somebody had a different battery system and they wanted to engage with us about bespoke design or a joint engineering discussion, then yes is the answer. We'd always entertain a discussion on that.
Perfect. Brilliant. We've got somebody asking about the current lead time and manufacturing capability of 310 and Papillio 3, but how long would that take from placing an order to receiving the unit?
Yep. So George and I were actually discussing this before the call. Quarter one of this year is very, very busy for us at the minute. We're pretty much fully stocked or fully under full order until roughly April. That said, we're manufacturing one every 3 weeks at the moment. So we would typically say around 6 to 8 weeks lead time from point of order. By the end of this financial year, we will be looking at manufacturing at one a week. We've got local source manufacturers set up in Scotland, or we're in the process of setting up in Scotland, and also in Wales as well. So the answer I would say is probably 4 to 6 weeks typically. I think we will be at a point by it's probably half two of this year where we would say sort of 2 to 3 weeks lead time. So the idea there is that we're going to be aligning with the period of time required to get your site enabling works in. But yeah, at the moment we're probably talking April. If you were to order one this week, April will be the earliest, and then sort of 3 weeks I would say thereafter.
Perfect. Brilliant. Mel's asking what size main supply is required.
So it's anything up to 250 amps. Will give you full performance. That will give you the full 22 kilowatt charge points performance across all 12 charge points. If you drop down to as low as about 128 amps, that will be roughly closer, I would say, to sort of 7.5, 8 kilowatts of charging rate, something like that, simultaneously or across all 12 charge points. So fundamentally, what we're looking to do, as I mentioned, is work with your existing grid connection. As long as that's not 0 or not 40 kVA, we're looking at something working with what's there. So to talk amps down to kVA, I think we're probably somewhere about the 80, 85 kVA, something like that as a minimum. Up to I think 250 amps is about 180 kVA, something like that. And please don't quote me on those. The conversion would need to be done, but I believe it's something like 80 or 90 kVA upwards. Size of the cable and things like that is obviously subject to distance from point of connection, or from feeder pillar to connection, but typically, 75 to 95 to sort of 120 mil is the size of the cables that we would typically use, three-phase and neutral.
Perfect. And then Anthea is the last question we've got. She's asking a little bit more about the wings that you mentioned in one of your previous answers, Jamie. Do they tilt to track the sun throughout the day, or are they in a fixed position?
No, we did look at the option of tilting, and unfortunately, it wasn't financially viable to look at the option of actually having them moving during the day. So they are fixed wing, but when we talked about them being in an upward or downward position, they can essentially be 8 degrees declined or 8 degrees inclined, if that makes sense. The water management system's designed that it would manage and control and obviously distribute the water subject to which orientation they're in. Now, if we're essentially east-west facing, then we'd have the wings in the up position. If we're north facing, then we'd have it in the up-down position, and then south would be in the down-up position. So it's mirrored essentially. So no, we don't track. They're not live moving. They weigh quite a bit, so it would cost us a lot to be able to do that. But we do have the option to obviously maximise the solar generation based on the existing layout of the car park.